So here we're going to look at the different types of elements and what state of matter they are in. Um, we will make a bigger, better version of this, but as far as the notes packet is concerned, there's three main types of elements: metals, nonmetals, and metalloids. So first you want to make sure that you note that the 8 metalloids, and on a lot of periodic tables there'll actually be like a darkened line creating a staircase that separates the metals from the nonmetals. And a lot of these elements on that staircase are what we call metalloids. And here you see 8 of them: boron in group 13, silicon and germanium in group 14, arsenic and antimony in group 15, tellurium and polonium in group 16, and astatine in group 17. And again, they divide the metals from the nonmetals. And so if you look at this picture, here we see the metalloids are still there, and then over to the right hand side are the nonmetals, and that's where the noble gases would be in group 18, our halogens: fluorine, chlorine, bromine, and iodine, nitrogen and oxygen that we breathe, carbon, graphite or coal, phosphorus on the tips of matches, and sulfur, giving us that nice rotten egg smell in like well water. And then don't forget over here our good buddy hydrogen. He's also a nonmetal, even though he hangs out above the alkali metals. So with 8 metalloids and about 18 nonmetals, that makes 26. The rest of the elements are pretty much metallic in nature. So the other 86 out of our 112 known elements are metals. And again, we'll make a bigger, better version of this in the computer lab in a couple days. But metals are exactly what you think they are. They are shiny. They are malleable, if you remember from Unit 1. I can hammer them and they will bend and shape and not shatter. Ductile. Ductile means that we have the ability to draw out the metals and put them into the form of wires, which, copper wire is predominantly how we get electricity around. And that's because they are great conductors of heat and electricity. They also have very high melting points. And so, like in that video that we saw, they talked about the Iron Age. Well, when you just burned wood, you didn't get the fire hot enough to melt the iron. Once they dug in the ground and found charcoal and were burning that, the fire got hot enough and they were able to melt the iron, and the Iron Age of Man began as they made weapons and other sturdier structures. Nonmetals are pretty much the opposite of metals. Metals are shiny, nonmetals are dull. Metals are malleable, nonmetals are brittle. If I hit them with a hammer, they shatter. They have very low melting and boiling points. All the gaseous elements, all 11 of them, are nonmetals. They've already boiled before room temperature. Many of them, at a way low temperature. And of course, they are poor conductors of heat and electricity, whereas the metals were good. And so, again, only 18 elements are considered to be nonmetals. The majority, again, are metals. And then we've got those couple metalloids. They have intermediate properties between the metals and nonmetals. Silicon is probably the most prevalent and important, used in microchips. And, thankfully for silicon, we were able to turn computers the size of rooms into handheld devices. And that's why out there in California we have Silicon Valley, where so much of the world's technology emerges from. But there you see again the 8 metalloids that are listed. Silicon, for example, if I hit it with a hammer, it shatters, a very non-metal quality, but yet it is an excellent conductor, which is a metal quality. Hey, school bell ringing. Sorry about that. But you can see that that's a definite intermediate type of an element. And then the last thing to note, this is a refresher from Unit 1, but remember on the periodic table, if it's a red symbol, then it is a gas at room temperature, blue is liquid, black is solid, and the outline ones are man-made. Alright, talk to you later.